Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I am the director of the Planetarium, and with me tonight is one of our students, familiar face if you've been here before, but I will still let him introduce himself.
Hi, I'm Eli. I'm a physics and astronomy student at UND.
So tonight we have another edition of Ask an Astronomer. So we are here to answer your questions. Forgot to check. I don't think we have any yet. So if you have questions for us, leave them down in the comments. In the meantime, we can give you a few kind of like astronomy updates and things that have happened. Although there's not too much to talk about today, sadly. I think the biggest news is the Inspiration 4 launch. So that launched on Wednesday, taking the first all-civilian crew. They stayed about 3 days up in orbit around the Earth, and they just splashed down about an hour ago. And so they are safely back. I haven't seen them come out of the capsule yet, but I know that there's all sorts of safety procedures that they have to go through before they can open the capsule. But from what I've heard, everyone's good, everyone's fine. They're just going through the steps to get them out. So, and it's pretty cool. I mean, the thought of having just civilians go into space, like, that's huge. We've seen it, like, one on a crew, but to have everyone, like, that's, I don't know. Eli, would you go if you were asked?
Yeah, I think I would.
Yeah? I can't decide, like,
I think I would.
part of me's like, I could say I went to space and see space. That would be awesome. And part of me's like, I'm terrified to even fly in a plane. There's no way my anxiety is going to survive a rocket ship.
Yeah. It depends. It depends on like how training intensive it was. Because like if training for it became a career, I would not want to do that. But if it was literally, don't press this button, get in the rocket ship and go, I would.
Well, so much of it is autonomous now.
Yeah, they don't really have to do anything. I don't think.
Yeah, I would imagine they would want at least one member of the crew able to like take over.
Right.
Which is why I think there was like a test pilot or something was one of the civilians.
Okay.
Um, but yeah, I don't know. All right, still waiting to see if any questions come in. Again, we are here to answer your questions tonight, so you can leave them down in the comments. I guess I should do my obligatory update on Percy and Jenny. They've been up to some fun stuff lately. So Perseverance is the latest lander or rover that landed on Mars. And Jenny is Ingenuity, which is the little helicopter that went with Perseverance, the first ever flight that we have taken on another world. Ingenuity, I believe, is now 13 or 14 flights. I can't remember. I feel like every other day it's just like Ingenuity made another flight. And it's just far exceeding everything we expected out of it. But some cool stuff with Perseverance. I know last time we did this, I talked about how it tried to do its first core sample collection, which failed. They got the sample drilled, but for some reason it didn't end up in the collection tube. But since then, Percy has now had 2 successful sample captures. And this is all part of a like next phase that NASA is planning. So the idea is Perseverance is going to collect a lot of these different samples, package them up, and leave them sitting on the surface for a future mission to actually come land, pick them up, and bring them back to Earth, which would be the first time that we've ever brought samples from Mars back to Earth, which is going to be huge. Now, we have actually studied Martian rocks in person, but the few we have are here because they're meteorites. they're pieces of Mars that got broken off from like a big impact, and those pieces were flung into space, and some of those pieces ran into Earth and fell to Earth, fell to the ground. So the only Mars samples we have here on Earth are those, and we don't have many. Um, so being able to get these back and also solidify a process where we can package up samples and then go and get them and bring them back, like that's going to change how we study Mars. It's going to be amazing to actually have stuff here in a lab that we can do. Because I mean, Perseverance, Curiosity, they're amazing. I mean, they're rolling laboratories, but there's still only so much that they can do. Um, so yeah, it's gonna be good. I think they're still working out all of the details on this return sample mission, but it's like the next phase of planned operations on Mars. So yeah, that's gonna be pretty cool. All right. Still not seeing any questions. Trying to think if there was anything else I saw. Pretty much all of the news lately has just been inspiration.
Yeah.
Yeah. Starlink satellites are still going up. I think I was reading, or maybe, no, I was talking to Bob King the other day, and he said the last batch of Starlink satellites were a new design,
Okay.
meant to use a different method to communicate between the satellites that was going to be more efficient.
Okay.
And I meant to look more into it, but yeah, that's happened. And talking with Bob King and some of the other members of the Arrowhead Astronomical Society, they mentioned how the Starlink satellites haven't seemed to have been as intrusive as they were at the start.
Mm-hmm.
So it does seem like whatever they started doing to minimize their reflectivity seems to be working, which is really great to hear. I don't know how it stands for like large research observatories, but at least the local amateur astronomers see an improvement in that. So that's great. Because that's been an ongoing discussion from the beginning, honestly.
Mm-hmm.
Ooh, hi Tad. Um, let's see. So we did just get a question. When meteor showers happen, are meteors hitting the Earth like bugs on a windshield, or are they being pulled in to Earth by its gravity, or a combo of both? That is a good question.
Mm-hmm.
I'm pretty sure it's mostly just running in, but I mean, gravity is going to also pull things once they get close, so it is probably a combo of both.
Yeah.
I don't
A
fully know.
combo heavily leaning towards bugs on a windshield.
Yeah, that's kind of what I'm thinking. I don't know the correct answer. For anyone who doesn't know, anyone who's watching, Tad is one of the educators at the Planetarium at the Bell Museum. So he's, yeah, nice to see you at one of our streams. Well, see you in the comments at least. I kind of want to look into that more though, because I hadn't ever really thought about that. Like when I teach it and like when we talk about it in here, it's always just Earth's running into the comet debris trail. But I mean, Earth's gravity has got to have some play in it because it's gravity. That's what
Yeah.
happens.
I just can't imagine it being a strong enough pull to like whip stuff in front of the Earth by the time Earth gets
Yeah,
there. I can't. It just doesn't seem super likely to
it
me.
would probably be a simple calculation
Yeah, super simple. If
to
I had paid,
see. Yeah,
um, I suppose it also depends on the size of the meteorite.
yeah, that's true. Okay, so yeah, Tad was saying that he's been asked that question before and
Yeah.
wanted to know our opinion. And yeah, I agree. I lean more towards bugs on the windshield,
Yeah.
but gravity probably does play a little
I,
part.
I kind of want to do it. Hold on, I'll be right back.
You're gonna do the calculation. I figured you might want to. I mean, you did a friction calculation for an egg on a wood table
Yeah.
for a show.
Yeah.
If anyone doesn't know what I'm talking about, this is one of the segments in the Astronomy Fact or Fiction show that Eli has been working on that he did last week or Wednesday. You did it on Wednesday.
Yeah. Yep.
Yeah. So anyone, if you missed that show, you can always go back and watch it. It's on in the video section of our Facebook page or posted on our YouTube channel. And you can find the link to our YouTube channel down in the video description. So while you're working on that, let me just plug one thing real quick. I want to remind everyone about the Allsky Camera that we have up at the Chippewa Museum and Nature Center at the end of the Gunflint Trail. So this is a camera we have on the roof up there, and we launched the website for it a little over a month ago, I believe. It is a part of our website, just one of the tabs on our website. And I'm pointing it out now because it's looking like we're finally going to have a clear night. We'll see. The past few nights have been cloudy and stormy, but we might have a decent night. So you can watch the live view on the website. You still have to like refresh it about once a minute to get the newest image to show. But that's there. We've got time-lapse videos from previous nights, archives of previous nights to find all of those pictures and videos and stuff. We also have a Facebook page set up for the camera that will post a post, I guess, every day when we have a new time-lapse video that's available, so you can get reminders when those come up. This has been a really fun project and one that we have been working hard on for over a year, and to see it finally live and working and in action, I'm very excited. So just sharing that with anyone who doesn't know about it, and there is a link to the site down in the video description. My sweet Allsky camera. And we've actually got a second one that we're going to be placing here in Duluth up on the roof of the planetarium. And I think it's really going to highlight kind of the difference in sky quality between us and middle of nowhere near the Boundary Waters.
Sorry, I'm kind of going in on this.
So you want to tell everyone kind of what you're doing?
Yeah, I can definitely try. I also don't know if what I'm doing is right, but I can definitely try. So I'm just, I don't want to call my picture things ugly, but so as the Earth moves in one direction, when, it doesn't move in a straight line because it's going in a circle around the sun, but just to assume, just to make it easier, we'll just assume a very short period of time that it's moving straight. And I'm just placing a meteorite with the average mass of a meteorite, which is just about 1/4 of a kilogram. And I'm placing it the average distance away from the Earth that meteorites are when they start burning up in the atmosphere. And I'm just going to see if the Earth would move out of the way before the time the meteorite hit the Earth to see if it really contributes or if it is only the ones that are directly in front of the Earth that collide with us.
All right, well, I'll let you keep working on that because we did get another question. This one's from my mom. Hi, Mom. And she's wanting an update on the new Deep Space Telescope, which actually is fantastic because that is one of the things that I had looked at to talk about tonight and completely forgot about. So thank you for that. So the telescope she's talking about is the James Webb Space Telescope. It's meant to kind of be the next generation of Hubble. And this has been being worked on for many, many years, has had a lot of delays, and right now is set to be launched in December. So it has been pushed back a little bit again. It was originally October 31st, and now it's looking like it's going to be in December. But we are on track for that to happen. The telescope itself is ready, it's done, it's packed up, it is shipping to the launch site. The rocket that is going to launch the telescope into space is ready and being shipped to the launch site. So really, it's just a matter of getting everything there and unpacked and set up for launch. So it's the light at the end of the tunnel is in sight, and this is going to happen. And this is going to be a major improvement on our space telescopes. One, it's going to be in kind of a different orbit than things like Hubble. So Hubble is actually orbiting around the Earth. James Webb is actually going to be put in an orbit around the sun. So it's going to kind of trail Earth. As Earth goes around the sun, James Webb is going to kind of just follow it around. And the benefit to this is, one, Earth isn't going to be in the way of our views, but it's also not going to interfere with any of our signals, because the Earth itself gives off a lot of infrared light, which is just heat because the Earth is hot. It also has a lot of radio signals, which isn't that important for James Webb. It's mostly the infrared that we're concerned about. And so being out away from that means that our signals that we're trying to get from space aren't being drowned out by the Earth's infrared light. And there's a lot that astronomers are planning to do with this telescope. I'm so excited for it. It's one of its purposes is to look at kind of very, very early universe and try and get a glimpse at some of the very first galaxies that formed, so that we can get a better understanding of how that process happened, which is definitely a subject near and dear to me. I did my research in grad school on galaxies and galaxy evolution, so I'm very excited for that. In fact, next Saturday, our next exploration show is all about galaxies. So if you're curious about that topic, you can listen to me talk about that for, I'm going to try and keep it to half an hour. But again, it is a subject I love. So I'm going to try and keep it short. I'm not going to have like a 2-hour lecture on you guys. But yeah, that's coming up. And of course, once everything is confirmed, we will for sure post information about it or share information about it.
So I got, and it's not exactly the answer in the form we were thinking it would happen, but so the average meteorite starts to be visible at about 120 kilometers. So I just assumed that as kind of our starting distance. That's not super valid because the gravitational influence by the Earth on the meteorite is going to start much before 120 kilometers away. But if it were the situation we're starting, so we have our Earth and we have our meteorite. If we start with them 120 kilometers apart at a, with the Earth moving forward, the meteorite would have to make a, so I kind of drew a little picture. So the meteorite would have to make a 33 about degree angle with the Earth and its like motion forward for it to get pulled in front and collide. And if it were making any angle larger than that, it would get like pulled behind it, kind of.
Okay.
So I think that's probably wrong, just because the situation that I assumed was difficult. But that's what I got.
No, but that's still really, it is kind of what we were thinking, right?
Yeah.
That the forward motion, like bugs on the windshield, does seem to be the biggest factor, but gravity does pull in some peripheral stuff.
Right.
So there's a little bit more hitting than would otherwise be. Yeah.
Yeah. So.
Very cool.
Yeah.
All right. Todd's got another great one. So when the Milky Way and Andromeda collide, which is going to happen in about 5 billion-ish years, what are we going to call the new galaxy? And I love my mom's answer. She says the milkshake, and I love it, and I think I'm going to agree with her.
I know I've seen videos where they call it milk dramata.
Milkdromeda. That sounds as cool. I like the milkshake.
That's what I've heard.
I don't know. I'm so bad at coming up with names and things.
Yeah.
But yeah. I mean, I'm sure they'll come up with some nice scientific-y name if we're even still here.
Yeah.
That's the other big question. Oh, is the human race going to survive for 5 billion years?
Yeah.
That's a big iffy one. Uh, yeah. All right. Well, I'm gonna do one last call for questions. And maybe I just got this idea. Maybe we can convince Tad to join us in the future. Have an outsider. Not really outsider. It's still part of the University of Minnesota system. I guess someone outside us will say. Yeah, I'm going to totally put him on the spot right now and see if he wants to join us in the future. All right, so last call for any questions. Okay, best example of a galaxy merger, and why is it the antenna galaxies? Yeah, I agree with that one. Totally agree with. Okay. Oh, my headphones are dying. I'm gonna leave that as a teaser to come see the show next Saturday, all about galaxies. Sorry, hold on. Let me take my headphones in. If you want to know what the antenna galaxies are and why they're so awesome, come see the show next week, next Saturday, when we do Exploring Galaxies, because then I can show you all about that. And yeah, I agree. That's one of the best. All right. So as I was saying, last call for questions. Give it a few minutes, and I can show you what's coming up over the next week. So on Wednesday is our rescheduled tour of the solar system. We were originally supposed to do this last Saturday. I ended up having to cancel it. And so we have rescheduled it for next Wednesday. So we'll take you on a tour through the solar system, get up close and personal with the planets, and learn some really cool stuff about them. And then, as I said, next Saturday is going to be our next exploration series, all about galaxies, which I am so excited to do. Other than that, let's see. Oh, Halloween. Yeah, we should hopefully have information about Halloween coming out in the next week. We still have a few details we're finalizing, but there will be a Halloween event. October will once again be Spooktober, where we'll be doing spooky Halloween themed shows all month. And we'll have kind of that calendar of shows out pretty soon as well. And yeah, I'm so excited for it. It's going to be great. All right. Well, I am not seeing any last questions, so I think we will wrap it up there. Thank you everyone so much for joining us. We hope you enjoyed this edition of Ask an Astronomer. Have a wonderful rest of your weekend, and we will see you again next time. Bye, everyone.